see your hand.
Hello, good morning. Anybody out there? Hello, somebody please say something. Live chat किधर है? Hi. Any questions, please? Anybody had any questions to ask? Kaushik, how are you? How are you, Kaushik? Do you have any questions, Kaushik? Kaushik, can you hear me? Sridhar, how are you? Vikash, how are you? Nice to see you. Can you please come up with ask your questions, please? No questions? Okay, let me ask you a question. Do you like the course? Do you like the course? Vikas, do you like the course? Kaushik, do you like the course? That's an easy question for you to answer. You can answer. You can type your answers in the chat box. Kaushik, do you like the course? Okay, Vikash, question is, what is Fourier series and why do we study them? You see, let me give you a very simple example. When you take in linear algebra, what do? What are eigenvalues? What are eigenvalues and where do we study? The eigenvalues of a matrix are the eigenvectors of a matrix are those vectors which are characteristic of the matrix. The matrix acts on an eigenvector and it gives you a collinear vector. Correct? And so those directions along which the matrix acts as collineation, they are interesting directions. They are intrinsic to this matrix. So it is of interest to know how many such directions are there. You have taken a 3 by 3 matrix. Suppose you find 3 different directions along which the matrix acts as collineation. Those are the natural vectors which are associated with this matrix. The E1, E2, E3, the standard unit vectors are not natural. So it is of interest to rewrite this matrix in terms of those eigendirections or those eigenvectors. Similarly, when you take a wire, when you take a string clamped at its 2 ends, take a string clamped at its 2 ends, you pluck the string like a sitar or a ektara, for example. You know the instruments, right? Ektara, only one string. Ektara, single stringed instrument. It is a folk instrument in India. You twang that instrument and then you get a musical a note comes out of it. Now generally a musical note is made up of various modes of vibration. The fundamental mode, the first harmonic, the second harmonic, the third harmonic. You see, if you look at waves, the sinusoidal waves, how many waves can be contained in the string, just the fundamental mode, half a wave, or the first harmonic, one full wave, or the second harmonic, 1.5 waves. Those are the fundamental modes of vibration of a string, and a complicated musical note is made up of a superposition of these fundamental modes of vibration. मैं प्रयास कर सकता हूँ हिंदी में बोलने की, लेकिन मुझे पता नहीं मुझे कितनी मेरी हिंदी थोड़ी कच्ची है, सो आई कैन नॉट एक्सप्लेन एवरीथिंग इन हिंदी. आप सितार जानते हैं ना, आप सितार का कितने वेव्स हो सकते हैं? फंडामेंटल मोड जानते हो? फंडामेंटल मोड, फर्स्ट हार्मोनिक, सेकेंड हार्मोनिक, इनको लेकर के एक मिश्रण बनाते हैं ना, C1V1 प्लस C2V2 प्लस C3V3 प्लस डॉट डॉट डॉट. ये जो V1 V2 V3 जो होते हैं फंडामेंटल मोड, फर्स्ट हार्मोनिक, सेकेंड हार्मोनिक, दोज आर द basis vectors. Similarly, in Fourier analysis, you are looking at expanding an arbitrary function as a linear combinations of some naturally occurring functions. So in the first 3 chapters, we looked at 1 cos x, sin x, cos 2x, sin 2x, cos 3x, sin 3x, dot dot dot. Later on in chapter 5 onwards, we pose this question: why sines and cosines? Why not other types of orthogonal systems? So Fourier analysis is trying to express general functions as linear combinations of these orthogonal systems of functions. Yeah? Vikas, did you get it? Vikas, समझ में आ रहा है? Kaushik, any questions for you? आप क्या कोर्स पढ़ते हैं? What are you studying? Vikas, can you tell me? और इंजीनियरिंग, मैथमेटिक्स, आप क्या कर, आपको कौन सा आपका स्पेशलाइजेशन क्या है? व्हाट इज योर स्पेशलाइजेशन? आप कौन से विषय पढ़ते हैं विश्वविद्यालय में? इंजीनियरिंग या मैथमेटिक्स? कौशिक, व्हाट डू यू स्टडी? व्हाट्स योर एरिया ऑफ स्पेशलाइजेशन? व्हाट्स योर एक्सपर्टीज? Oh, BSc Math, second year. Okay, good. Very nice. So for a second year BSc Mathematics, this particular NPTEL course might be slightly advanced, but never mind. You're getting a good exposure to very fundamental part of mathematics. So, Kaushik, you're doing MSc in MS University Baroda. Very nice, very good university. Are you studying analysis? Measure theory, general topology. Now you're beginning to see how measure theory, general topology and functional analysis apply to Fourier analysis. So Vikash, it might be a little difficult, but doesn't matter. आप लगे रहिए. ये जो later when you study more and more, ये जो videos जो है आप देखते रहना. You have to return back to this several times. First time, at one stroke, you cannot understand these things. You need to look at multiple iterations of. Good. This will be useful for your JAM preparations also, and you need to look at these videos several times for you to get some useful stuff. It is true even for people who are doing MSc. It's even true for Kaushik also, he will have to look at it multiple times. Everybody, all of you will have to look at it multiple times in order to get the full essence of it. It's a slightly difficult course, but that's exactly why this course is given online, so that you can keep on looking at the videos again and again. So are you, Kaushik, are you taking this course as an optional subject? Have you opted for Fourier analysis in your MS University Baroda? Okay, let me also give you my Gmail address. Please write down. If you have questions, I can also answer on the Gmail. You can send me a Gmail if you want to get in touch with me. Because you are doing MSc in you want to do your MSc in IIT Bombay. I thought you said you are doing a BSc Maths second year. Vikash, I didn't understand your last comment. Are you doing MSc? Was a BSc a typo? You said BSc Maths second year. Is it a typo? Are you doing MSc Maths, or are you preparing for JAM to come to MSc in IIT Bombay? I'm interpreting this as saying that you are preparing for after IIT JAM. Okay, good. Yeah, so you will learn a lot in IIT Bombay. That's a very nice, good idea. So we can meet when you come to IIT Bombay. Good. So if you don't have any further questions, please write down my email address, and please feel free to send me an email what your doubts are, what your queries are. I'll be happy to answer them. Yeah. All right. Any further questions, please? Okay, I think if you don't have any questions, I'll close this session in about 2 minutes. If there are no further questions, I'll probably close it in 2 minutes. The history of Naman, the history of Fourier analysis. It's a very long and very difficult and a very complex chapter. Fourier analysis began with Joseph Fourier, and he tried to write that's exactly what you see in the first lecture, and I've given you a number of references. So the history of Fourier analysis the Fourier analysis started out with, even Euler and Bernoulli also tried to write down these arbitrary functions in terms of Fourier series, and the motivation came from solving a wave equation in 1 dimensions. But the problem is that, as explained in my very first lecture, this is not this was not very favored, because the initial conditions appear indirectly in the Fourier coefficients, unlike other formulas like the Poisson formula for the harmonic functions, etc., where the solution is directly written as an integral. So And then what happened was that in the middle of the 19th century is when Fourier analysis really took off as a specialized branch of mathematical analysis. I mean, analysis took a turn in connection with problems in Fourier series. It was Riemann who really rethought, who really got the idea that the notion of integration has to be radically revised. So the theory of Riemann integration started. Then as the decades progressed, they realized that the Riemann integration, though very good and very rigorous, had a certain incompleteness about it. And then the Lebesgue theory developed. So the theory of Lebesgue integration should be thought of as a completion of a certain project started by Riemann to put the study of Fourier series on rigorous foundations. And it is exactly the same questions that led to the development of Lebesgue integration also led to the development of point set topology. This is a very interesting phase in the development of analysis. And the best references is the book by Roger Cook. Roger Cook has written several books on the historical developments of analysis, and I think you should look into this. Complex analysis did not per se develop out of Fourier analysis, but it became a very convenient and a very useful auxiliary to Fourier analysis. There are close connections between complex analysis and Fourier analysis. This appeared much later. Vikash's question, what is mathematics, is a difficult question. In response, let me just write a reference. Courant and Robbins, they wrote a beautiful book with the title, What is Mathematics? That exactly is the title of the book. And I think everybody who aspires to be a mathematician must read this book. Everybody who aspires to be a mathematician should read Courant and Robbins' What is Mathematics? Any other questions, please? And Laplace transforms, yeah, they are related. Fourier transforms and Laplace transforms are close cousins. Fourier series is very important because Fourier series basically is a study of symmetries, and they're exactly as I explained. They're basically eigenfunctions expansions in terms of eigenvectors. The sines and cosines are eigenfunctions of the Laplace's operator. Fourier analysis basic book, Folland. That is there in my slides. Folland's book. G.B. Folland, Introduction to Fourier Analysis. The references are there. You can look at Strichard's book. You can look at Mark Pinsky's book. Number of references are given in the slides. Look at the slides, you will find it. Or feel free to send me an email and I'll send you the more references if you like. Yeah, Fourier analysis is a very important research area. Very important area of research. That's correct. I mean, it'll go under the name of harmonic analysis. The modern Fourier analysis is known as harmonic analysis. Okay, then I think if you don't have anything specific, we will close the session here. So I've given you my email address. Please respond if you want. Again, I'll be happy to answer questions on the email also. Bye-bye.